Welcome back, Performance Pros. This week covered topics from peptide interaction networks to injury repair, mitochondrial targeting, gut integrity, next-generation research, hydration, cardiometabolic signaling, and peptide clearance. If you missed any videos between 146 and 159, this recap will connect the entire week for you and give you the big picture. We started with peptide interaction networks. Peptides never act alone. Pathways overlap, reinforce, block, or redirect each other depending on the biological environment. Inflammation influences metabolic demand. Stress influences hormone rhythms. Growth pathways change behavior when recovery pressure is high. Signals only matter when you understand what network they enter. Next, we looked at bone remodeling. Bone is constantly rebuilt through the balance between osteoclast breakdown and osteoblast formation. Research peptides like BPC-157 and TB-500 appear in models that explore collagen structure, angiogenesis, and local repair environments. Bone health is a signaling process, not a calcium problem. Then we moved to gut barrier integrity. Tight junctions rely on precise peptide signaling to stay sealed and adaptive. Research peptides like BPC-157 and GLP-based fragments appear in discussions about mucosal repair, epithelial turnover, and immune balance. When that signaling stays organized, the gut protects the entire body. When it breaks down, inflammation spreads to every major system. After that, we shifted into hydration and electrolytes. Fluid balance determines how well peptides circulate, how quickly they reach receptors, and how stable signaling becomes. If electrolytes are off, transport slows, blood volume changes, and cellular balance becomes unstable. Hydration is a signaling stabilizer, not a comfort measure. From there, we examined cardiometabolic health. This system combines vascular function, metabolic flexibility, inflammation control, and mitochondrial output. MOTS appears in research tied to AMPK activity. SS31 interacts with mitochondrial membranes and oxidative stability. AITR-based research connects to energy balance and endurance models. Cardiometabolic health is about coordination. When signals are clean, energy and performance stay predictable. We then looked at the next 5 years of peptide innovation. The future is not about stronger peptides. It is about smarter, more stable, and more targeted ones. Research is moving towards selective activation, mitochondrial targeting, nanocarriers, and designs that resist rapid breakdown. SS31 and MOTS inspired sequences are early examples of where this field is headed. Next, we broke down peptide targeting. Peptides do not search for tissues. Receptors decide where they bind. SS31 naturally concentrates in mitochondria because of cardiolipin affinity. MOTS interacts with metabolic tissues due to AMPK-linked pathways. Follistatin-related fragments show muscle-associated activity. Targeting is passive. Biology creates the selectivity. We then compared acute and chronic injuries. Acute injury uses fast, high-intensity signaling for cleanup and regeneration. Chronic injury is defined by stalled repair, scar tissue, inflammation, and noisy communication. Research peptides like BPC-157 and TB-500 show up in models that explore how repair environments shift in these two scenarios. Finally, we looked at peptide clearance. This is the part that determines how long a signal lasts and how strong it becomes. The liver, kidneys, and circulating enzymes break peptides down, filter them, modify them, or clear them. GLP-based fragments break down quickly. MOTS shows clearance patterns influenced by the kidneys in research. SS31 resists rapid breakdown because of its structure. When clearance is too fast, signals never build. When clearance is too slow, receptors desensitize. Across all 14 videos, one pattern stands out. Peptide biology is communication biology. You are not influencing one pathway. You are shaping the timing, strength, and clarity of signals that guide repair, metabolism, stress response, and cellular activity. When signaling stays organized, everything feels smooth and predictable. When signaling becomes chaotic, every part of performance and recovery feels harder. Comment below and tell me which topic from this week you want turned into the next long-form deep dive.